Hey there, we are continuing with logarithms. We're in section 5.3, and logarithms can be a little intimidating, so just stick with me, do lots of practice, get a lot of help from the help menus. You will be successful. So let's just keep going with number 7. We'll burn through a few of these because it starts to become the same kind of thing, and you get really used to it. So if you see log of 1, this actually means log base 10. Until you get used to it, I just want to note that this is the common logarithm, log base 10. Now remember, this is y. To always do that and then go, this means 10 to the y equals 1. Well, we've kind of seen this already. That's when y equals 0. The only way to make 10 into 1 with an exponent is the 0 exponent. So this is a rule in general. The log of 1, any base, is going to be 0. Let's keep going here. So this is an unusual looking one. It has a log base 7, and then it has a 7 to the 4. And you got to be careful there. That base 7 is separate from that. So all right. So there we go. Again, it's an exponent. Logs are exponents, so this means 7 to the y is 7 to the 4. Y is just 4, so not a lot to do there. Something we're going to be doing in the next section is this log base kind of cancels that exponential base. They kill each other off. Y is just 4. All right, but we're not quite there yet, so we just got to keep getting used to it. All right, so 9 is same kind of problem, but just has an uglier input there, fourth root of 5. So remember, it's y. So y, 5 to the y is equal to 5 to the quarter. I mean, there's just not much to it. That quarter exponent looks like that. So it just tells you right away, oh, y must be a quarter. They are exponents. Okay, let's fly through a few of these. So the log base 10 and the 10 cancel each other, and you get minus 5. The ln, I guess we should maybe do this example just because it's kind of different. When you see ln of something, that is actually not the common logarithm, but that's the natural logarithm. Now, the natural logarithm has a base of e. So, again, we're saying this logarithm is y. E to what power is e to the minus 1? Well, the answer is just minus 1. Not a lot of work to do. The log base e cancels the base e. And so you just pick off the exponent there. You don't have to do a lot of work there. So minus 1. So you can pick these off really easy. So the ln of e to the 12th, well, this has to be the 1/12th, the 12th root of e. The ln and the e kill each other off. All that's left is that exponent, the 1/12th exponent. Let's just convert. Next couple, let's say convert to a logarithmic equation, starting with an exponent equation. So the logarithmic equation is you write it as logarithm. So you go log of 100,000 must be equal to 5. Remember, the exponent is 5, so the 5 is going to go over here. The log of that thing, the base is the common logarithm, so I'm leaving it out. Let's do another one here. So the base here is 16, though. So when you write your log, you're going to say 16 base, and you want to take the log of 4, and you want to get back the exponent. The exponent is a half. So we're just converting an exponential equation into a logarithmic equation. Same here, but this is ln this time. Ln of r must be minus 3. Minus 3 is the exponent. R is the thing that we're getting after we put that exponent on the base e. All right, now this one, you start with the logarithm. They want the exponential equation. So remember, what does this mean? This means 5 to the 3 power is 125. That is the equation. All right, that's the exponential form of the equation. All right, we are almost done with this section. So use a calculator to find the common logarithm. So let's just barrel through the common logarithm on the calculator. Right here, right next to the 7. So you say log 33, hit enter, and they want how many decimal places? 4 decimal places. So you'd say 1.5181. Ooh, 85, and it doesn't round. All right, so that's log of 33. Now the ln of 93 is also on our calculator. It's next to the 4, and so you take the ln 93, hit enter, and you get 4 point. They want 4 decimal places again. 0.5326. 0.5326. Pretty easy, isn't it? The last two, we actually started with this in the previous video, the change of base theorem. We actually don't have a log base 7 on our calculator, so this really comes in handy. So let's do number 19 here, log base 7 of 80. Now, so what you do is you convert it to the common logarithm and by the change of base formula. So you take the log of 80, you divide it by the log of 7. Let's actually do it on the calculator. Log of 80 divided by the log of 7. So the log base 7 of 80 is 2.2519. Now what this means is that is the exponent that if you took 7 and raised it to that exponent, you would get 80 back. That's what we're talking about here. Is what is the exponent on that base that'll create that value. And okay, so the last one there, log base 5 of 13, using the change of base formula. Now I'm going to use the natural logarithm this time because it turns out you can use either one. We have both of them on the calculator, so you can do the ln of 13 over the ln of 5. So that'd be the ln of 13 and divided by the ln of 5. And so we get our answer of 1.5937. 1.5937. Now keep in mind, what we're saying is that if we took 5 and we raised it to the 1.5937 power, it's going to be close to 13. Now, it's not exactly 13 because I didn't use all the decimal places, but it's in the ballpark of 13. That's what we're getting at. And it didn't matter if we use the common logarithm or the natural logarithm, as long as we're consistent about which one we put in the numerator and denominator, we get the same answer. Hey, thanks for watching.